This is again a video that was done at the Busman Lab in St. Louis quite some time ago. And this was a test, obviously. Some of you have seen this before, and some may never have seen it. It surprises me sometimes when folks haven't seen it yet because it's been around quite a while. But what happened here, basically, this was a electronic trip circuit breaker. It was set at 640 amps. They were looking for around a 12-cycle clearing time on this one. Obviously, a 60 hertz system, 60 cycles a second. And so 12 cycles was the clearing time that they were looking for. It actually, they were creating the arc event inside the disconnect enclosure where the mannequin's hand is. And it cascaded up into the wireway, which you'll see in the upcoming photos and video, hopefully, if that all works out today. So it was a 480 volt circuit, and there were 22,600 amps of available fault current at this location. So from this event, and one of the things I want to mention here right now, and because I know we're not going to have a lot of time to talk about it today, but when we talk about the term working distance, when it relates to arc flash, most arc flash labeling or arc flash energy information will give you, if it's done in the other than the PPE category method, and even then you'll have a working distance. You're going to have a working distance, let's say, of 18 inches, and it really relates to the type of equipment and how deep the equipment is. Is it, standard equipment like this one where they use an 18-inch working distance, or is it something that's deeper, like more into the larger equipment that's 24 or 36 inches deep? And it's really the distance between the source and the worker's face or chest area. So I just thought I'd mention that, because I don't think we really get into discussing it, because I don't have time to get into the labeling requirements and all of that stuff today. So I wanted to mention a little bit more about what the working distance was here now while I had the opportunity to do that. So like I said, the distance from the source to the face and chest area, and you have to remember that number, that heat energy in calories per centimeter square, is going to increase the closer I get to the source. And that's always an important thing to remember when you talk about arc flash energy. Okay, so these are the still shots from that event that you just saw. So this is the early onset of it, the beginning of it. These are in like 1/10 of a second intervals. And then you can see the intense light now that's coming from it. You can see it took the wireway cover off. They're not really hardened bolts holding. Those are kind of soft, smaller screws that hold the wireway cover on. So you can see it actually took the wireway cover off of the equipment. So it cascaded up into from the original intended point, which was in the disconnect switch or in the switch, and it went up into the wireway, caused a secondary fault in the wireway, and then the overcurrent devices that were protecting the test laboratory actually opened in 6 cycles, and so they opened before the other device did, and shortened up the actual time. So it was interesting the way that all took place. And then you can see the wireway cover actually getting ready to hit the mannequin in this particular point. And you can see it's pretty much a whiteout at this point. You can see the shrapnel and things like that, all the kind of highlighted stuff over here in this area to the left of the slide. That's all the shrapnel all the metal that's being vaporized as this arc flash event is occurring on it. And you can really see it in this picture. You can see all the shrapnel that's being spread around. And one of the other things is you can see the gases. There's probably plastic and things that are burning inside of there, and we get to inhale all this stuff while this is going on at the same time if we're not thinking along those lines. So again, just an example of what can occur. And like I say, a lot of folks have seen this. So if you do, it's kind of a review for you. And then pretty much towards the end. So here's where some of the test results in this. You can see the loud sound, 141 dB at 2 feet from the mannequin. And again, 140 dB can cause serious hearing damage. You can see it was 2,100 pounds a square foot per square foot of pressure on the chest area. So that can certainly create broken ribs or damage, internal damage there. But there's a couple of things I really like to point out at this particular slide. So you can see that when we talk about the temperature here in this, you can see that it was 437 degrees Fahrenheit at the chest area, and it was 437 degrees at the hand area. And interestingly enough, it pegged the meter. So they really don't know how high the actual temperature went in this illustration or in this event. So it obviously, if it was 430 degrees at the chest and neck area, then it was going to be a whole lot higher than that at the hand area. And of course, like I said, it was pegged the meter in both places. But here's the thing I like to point out as the other important thing here. The mannequins had arc-rated garments on, and when we discuss them in a longer day, we'll talk about ATPV ratings and E sub BT, which is E sub BT is a break open threshold. It's where the garment actually broke open, and ATPV is heat flux. It's heat transfer from one side of the garment to the other side of the garment. So the heat on the outside versus the heat on the inside. And if you look at this, we know that the heat was at least 437 degrees and certainly higher than that on the outside. But you look at the 122 degrees Fahrenheit on the inside of the shirt under the garment, which was below that second degree burn threshold. So the garment did its job. And that, to me, that's one of the most important points, or one of the real highlights of basic 70E, is to realize that the garment will protect you from that thermal value. The tough part is dealing with the pressure waves. How do it's very difficult or not impossible for a cloth garment to provide any real degree of arc blast protection. But again, discussion for a longer day.